Hi, here we've got the final iteration of the ATX lab bench power supply with external trigger input. Starting at the main side, we've got an IAC power cord with the PSU's original Farad choke, because why not? This of course goes over to the back of the unit, where we have installed an additional mains power indicator LED, which is soldered directly to purple and to ground, like this. On the top of the unit we've got a few safety labels, not because they are necessary, but because I borrowed my mom's label maker and things got a little out of hand. On this side, got a short description of what exactly this thing is all about and what the additional terminal means. And on the other side of the unit, we've got all the rated voltages as well as the maximum current we can draw. At the 3.3 volts rail, which is orange, we've got 15 amps, 5 volts, red 21 amps, and 12 volts, which is yellow. We've got 20 amps permanent and a peak current of 38 volts. And unfortunately, this is a 230 volts 50 Hz supply only. As anyone still makes single voltage supplies, I don't have the slightest idea, but oh well. On the bottom of the unit, we've got the original label, in case I need any information over there, as well as a few of these self-adhesive felt furniture glider thingies. The front of the unit, I've bolted a few plastic junction boxes to the side. 3 individual ground terminals, because that's what I like. These are all bonded together. 3.3, 5 and 12 volts. And here we have power on indicator, soldered to gray and ground, as well as our power switch. The external position connects the green line to this socket here, and the permanent on position connects it to ground. And of course the protective earth is brought out to the front and can be used here as well. 3 volts works fine. And by the way, you can silence an annoying piezo buzzer by placing a coin on it. And of course, we've also got 5 volts. Of course, the main point is not to play with that, but as demonstrated in the last video, to actually have your external trigger connected. You know what? Much better. You know, actually, notice how the green on light actually comes on tiny bit later than the power does. That is of course because that's actually the power good signal. Just putting an external switch on there doesn't make much sense, but you could put any external trigger you want on there and switch your load and your entire power supply without any additional transistors or relays, which is really nice. You know, for crude experimental setups in a quick and dirty way. So just for demonstration purposes, here we have 2 incandescent light bulbs and a piezo buzzer running off 3 volts. And yeah, this thing, it's really bloody annoying, but it will allow me to demonstrate how this works. And actually, demonstration purposes is one of the main goals behind this. You know, because you could whack basically anything on there, and then without having to bother to build any elaborate switching mechanism, you could just demonstrate your project. And here we've got our external trigger, 2 simple electrodes, of course connected to external trigger input and ground. And if you touch these to any metal surface, of course you will get the annoying buzzer. Now this thing reacts a little slow for this to be used as a continuity tester. In fact, it's akin to a very, very bad Chinese-made multimeter. But what of course you can do is attach these two to a microscope slide with a binder clip. And now you've got yourself an impromptu moisture sensor, or rather a water level alarm. So if I put a few drops of that was annoying. The trick, if you actually want this to turn off and give a pulse with every new drop instead of just staying on permanently, is to cover the electrodes just in the tiniest amount of WD-40, and then it will not stay on because the liquid will not pool up on there and form a bubble. So more like I actually have a video on my channel, the last video before this one, where I built a timer with a dripping IV line and a bit of saline with just these electrodes and this power supply. So yeah, this works, and it actually works pretty reliable. So if you want to watch these shenanigans for 10 minutes straight, go look for my entry to the Flashing Light Prize 2017. But other than crude experimental setups, you can also abuse this thing just to have fun by taking the speaker mic off your ham radio and attaching the PTT button to the external trigger. Actually, I think this is a tiny bit slow to practice Morse code with. Yeah, no. But it's fun. To summarize, if you're building one of these tiny bench power supplies from an ATX power supply, I really suggest to put in an additional jack for the green line to connect to, instead of just connecting the green line to the switch, so that you can plug in an external trigger to switch your devices for shenanigans and also for quick and dirty experimental setups. External trigger. It should be noted, by the way, that especially compared to other cost-effective alternatives, these things are fairly consistent and stable in what they put out. And that one tends to settle there. Yep. And this one usually tends to stay stable at 12.11 without a load. One thing is remarkable though, how much power these can actually provide, especially again when compared to other affordable alternatives. Two of these gimmicky air compressors for shader valves, they run off 12 volts. I have one in my car for emergencies and the other one I use for my bicycle. However, these run perfectly fine off just your car battery, you know, directly from the cigarette lighter plug. And they take, well, nominatively, focus, thanks, 6 amps. So if I want to use this inside to pump up my bicycle, I've got this inverter, no, not inverter, power supply unit, very cheap, Chinese made, which is supposed to also be able to deliver 6 amps. So this should not be a problem, right? So this should work, right? This unit is powered up, and if we plug in the air compressor and switch it on, yeah, nothing really happens. So, well, this thing takes 6 amps. The peak current when it starts up, what do you call that? Inrush current, when the pump starts up, is much higher. So I didn't have much luck with running this compressor of a cheap power supply. With the ATX power supply, however, to summarize, this very basic, fairly easy to build power supply is actually pretty decent, and I still think everybody who builds one should put in the external trigger input, just so they can play with it. Thanks for your kind attention.